All right, everyone, welcome in, welcome in. Thanks for joining. And we're working on LeetCode today. Here's the Latterly LeetCode kata. This is the evidence-based approach suggested by Latterly. You can sign up for free at latterly.io. You can also come join the Discord if you have questions. But if you sign up, it'll help you land your next or first programming role. And you get access to this free checklist. Walks you through step by step how to go get that first programming role. And then there's some advanced tips that you can unlock for as little as $1 a month, and live sessions like meetups and stuff for the premium tier. Okay, so the main goal today is to get through longest substring without repeating characters and then work on linked list. I don't know if we'll get done with linked list. But the kata approach is a memorization-based approach, so you go from the top every time. So we'll be starting with 2-sum and 3-sum. The goal is to get through longest substring without repeating characters within 30 minutes. If I don't get done with it in that time, I will time box it and cut it off. Ideally 20 minutes or less, but 30 minutes is where I'll pull the plug and like look at the answer and stuff. And that will leave us at least 30 minutes to work on linked list, which is this an easy one? As I recall, I think it's an easy one. Yeah. So hopefully we're going to get through that as well. And if we get done with all of them, I won't be proceeding to palindrome today. We'll save that for tomorrow. If we get done with all of them early, it'll just be a shorter stream. If you're on TikTok, tap the video to give it some likes. You can tap it more than once and give it a bunch of likes to help the algorithm send it around. And if you're on YouTube or Twitch, unfortunately, I think you can only do 1 like, but I would still appreciate the 1. And with that, let's dive in. So I'm going to wipe the previous solution, mark it as to do, and we'll walk through this as if I were given this problem presently on an interview. So we start by reading the question and then thinking through edge cases, taking notes, pseudocode, and finally writing the code. So the description is, given a 1-indexed array of integers called numbers, it's already sorted in non-decreasing order. So an example would be 0, 0, 0, 1, 1, 1. You can have repetition, but it won't decrease. Find 2 numbers such that they add up to some specific target. Let the numbers be called the first index of numbers and the second index of numbers, where they're going to be between the number 1 and the length of the array. So we want to return the indices. That's an array that should always be of size 2. We want to return those indices, not the values. Solution must use constant space, and we are guaranteed that there's exactly 1 solution. So we don't need to worry about the sad case where there's no answers. We don't need to worry about handling multiple answers. Given that numbers is already sorted, I think I can use 2 pointers. In the worst case, I need to scan the whole array. So worst case, time complexity appears O of n. Memory complexity for the pointers is O of 1, i.e. constant. Okay, so I'll make a left pointer at 0 and a right pointer at length of numbers minus 1. We will eventually return 1-indexed pointers. So we'll do left plus 1, right plus 1 in order. Okay. So how do I calculate the current sum? I need to iterate through the list of numbers, and I'll iterate on left is less than right. While left is less than right. The current sum is the left index of numbers plus the right index of numbers. And then there's a few conditions. If over, else if under, else match found, return. Good. So over is cur sum is greater than the target. Under is cur sum is less than the target. Thank you so much for the likes. Thanks, Bathsheba. Good to see you. Let me make sure I have the chat open for Twitch and YouTube as well. Okay, so if the current sum is too large, I want to move my right pointer to the left. Since it's sorted in non-decreasing order, taking my right pointer and moving it to the left will result in a reduction of the total current sum. So here, right plus or minus equals 1. And in this case, I want to do the reciprocal, plus equals 1. So I'm taking my left pointer and moving it to the right to grow the overall cur sum. Okay. There's our solution for 2 sum. Now let's continue with 3 sum. Given an integer array nums, return all of the triplets, I of nums, j of nums, k of nums. So these are the values, not the indices. And we want to return all of the triplets without duplicates. Here we can see an example case where the output is an empty array. So we do need to handle the sad case where there are no answers and the case where there are multiple possible answers. And in this case, the target will always be 0. So we don't get a variable target, it's just always 0. So the intuition here is to take an optimal 2 sum and then wrap it in an outer wrapper index, which adds an additional O of n time complexity. Intuitively, we can target O n squared time complexity by using a wrapper around an optimal 2 sum. The wrapper is just a pointer, so memory complexity is constant. Harambe, good to see ya. Here to have you body double while I speedrun a microservice. Rock on, good to see ya. Okay. To use the optimal 2 sum subroutine, we must sort. This takes n log n time complexity, but it is not asymptotically binding. So we start by sorting nums, nums.sort, and then here we will do results are a set for auto deduplication. We will store tuples inside. 3 sum, let's get it. What's up, Isaiah? Going through the kata, memorization-based approach, so we do these over and over, and we'll add a problem as often as we can. And then we need the wrapper index. Start that to 0. And sometimes I call this like left or super left or far left. It's going to be left of our 2 sum left. So while the wrapper index is in bounds, call 2 sum, and then fast forward on duplicate values. A wrapper index like M&M. Yes, exactly. will eventually return results. Now let's go make a two-sum. Here I'll follow the Python convention to underscore case the function name. Okay, so self.toSum, and we will want to pass nums, the wrapper index, anything else, the results, and the complement. So the complement is what's going to allow us to find the target for the inner two-sum. If the complement, say, is -2, then my target for the two-sum becomes -2. I return those values, then the sum of the three, the wrapper index value and the two-sum tuple, the sum across those three is guaranteed to be 0, which is my goal. So the complement is the opposite of the wrapper index of nums. Okay. So we fast forward on duplicate values this way. The opposite of the complement is the wrapper index of nums. So I'll say while the wrapper index of nums is equal to the opposite of the complement, we will increment this. And notice that this is guaranteed to hit. It's tautological on the first iteration. It's guaranteed to hit. So I don't need an exterior increment for wrapper index. This is going to handle it. It'll take care of that first iteration guaranteed, and then it may take care of many others if they exist. Thanks for the follow. If you're on TikTok, you can tap the video so the video will be sent to other potential viewers. Tap it to give it some likes. Thank you so much. Okay, so this takes care of fast forwarding on toSum. But there's the possibility that we're out of bounds. So I need a prior condition to make sure that the wrapper index doesn't go out of bounds. So I'll say while the I can just basically repeat this expression. So I'll say while the wrapper index is less than the length of nums, and here's my cache equivalence condition, basically. If it's the thing equivalent to what I'm already on, let's skip forward, and we can avoid the overhead of calling toSum. That's the whole point. Okay, I think that's looking good, so let's build out toSum. I'm going to do this in the same order provided. So nums, wrapper, IDX, results, complement. And here I'll just call it target. So the complement is the target. toSum left is the wrapper index plus 1. So I'm only exploring the slice or the sub window to the right of my wrapper index. And then the outer bound is equivalent. The outer bound is still going to be the outer bound. I think it's -1 because we're going to look up on an index. So I want to say while left is less than right. Need to calculate my current sum. This is left value is going to be the left index of nums. We'll extract that because we will eventually use it for our cache condition. Okay, so here's the current sum. In our three cases is we can be over, under, or equal. So if current sum is equal to the target, else if current sum is less than the target, else we are over target, or like move right pointer left to decrease current sum. Does that make sense? Trying to decrease space complexity. Yeah, we need to keep it constant. I actually don't know that we need to. So the solution doesn't require us to, but it so happens that the optimal toSum is already constant memory usage. And we can have optimal performance with only a pointer. So if we can do that, then like we totally should, right? Just to avoid extraneous space. You could have a solution that takes up more space, but it's not necessary. Last night, I nuked our prod database, and as a result, I've been shaking for 15 hours. I'm so sorry. That's terrible to hear. If there's anything I can do to help, join the Discord, latterly.io, and DM me after the stream. Is it better now? In the meantime, you probably, like, as much as I love you being in my chat, you probably shouldn't be in my chat right now if prod is down. But yeah, if there's anything I can do to help. Waiting on help. Okay, cool. All right, so let's continue. So we have the three conditions. Here's the equality condition, match found, append to results as ordered tuple. Okay, so we'll make a sorted tuple here, and that's going to be left value, nums, right, and really I could call this right value and avoid repeating myself and gain a little bit of code consistency. We love that. So here's left value, here's right value, and then prior is the opposite of the complement, which is my value for the wrapper. Those are the three values in order. They're guaranteed to be in order. Does that make sense? So that's called my sorted tuple. I don't need to call sort. They're guaranteed to be in order. And I just want to take my results and add it. So because a tuple is hashable and immutable, I can add it to a set. So results is a set with an S, just making sure I included the S on the argument name. Sometimes I forget that and call it result, and that's always a problem. Okay, so this is the match case. And then we want to fast forward at this level as well. Fast forward duplicates. Saves us some runtime. We know that we want to avoid duplicates anyway. So I'll say while, and I could perturb the left or the right, but I'll just perturb the left because that's, again, consistent with the wrapper index moving left to right. Just keeps everything simple and consistent. So I'll say while the left value of nums is equal to my cache condition, left value. And you see, once again, this is guaranteed to hit once. Now I need to do my check to ensure that I'm in bounds. And that looks good to me. That looks good to me. So we'll always hit once and we might skip a few times. Okay, what about the case where the current sum is lower than the target? Then I want to take my left hand and move it up. What about the case where we're over target? Move right pointer left. Cool. Did I misspell complement somewhere? Complement, complement, complement. Oh, and then I call it target down here. Okay. And we are passed on free sum. We're progressing in the kata, moving on to longest substring without repeating characters. We're at the 18-minute mark, so we're on time. Let's wipe out the solution and read through the problem as if we were just presented. So given a string S, find the length of the longest substring without repeating characters. So intuitively, if I'm allowed to repeat characters, then it would just be the length of the entire string. And this is a limiting worst case for the present problem, because the sort of the worst case iteration here is that there are no repeated characters. Just like the string that you give me, it doesn't have repeated characters anyway, like A, B, C, D. The substring will be the entire string. So we know that we potentially need to scan the whole string. So in the worst case, there are no dupes. So the longest substring is just the whole string. So I must scan the whole string. So time complexity is O of n. Does that make sense? Now the question becomes, what do I need to do with my memory? We're going to need some pointers for sure. Can we make use of some sort of cache? And the answer is yes, because I want to remember which I've seen. For memory, I want to remember seeing characters. In the worst case, this will be all characters up to n minus 1. So memory complexity is worst case O n minus 1, which is asymptotically, we just say which is equivalent to, if I can spell equivalent or asymptotic. Can we just get some simpler words? I guess they were all used, weren't they? By the time 1950 rolled around, we had all the other words used. Could we use a loop and add each character to a set, then compare? Absolutely. So if we add each character to a set, which is exactly what we will be doing, the following is still true, that the worst case memory complexity is O of n minus 1, because you might need to store every character up to the last character. Does that make sense? Ben says, memoize it. Is memoizing the same as caching? I feel like the answer is yes. Is there a difference between memoizing and caching? Memoization is a specific form of caching that involves caching the return value of a function. We are not doing that. We are merely caching values. We're merely caching values. I mean, you could call it a memoization because you can construct some function which will return the value that we're caching. It's like an exercise of imagination that we don't need to do. I guess the terms are roughly equivalent. You could create some function that would output the thing that we're caching. I think it's simpler to just call it a cache, but whatever. I also sometimes call it a scene map, because there's this idiom where you make a hash map, which is for things that have been seen. And you could use a literal scene map or a hash map here, but I think I want to use a set instead. What would be the difference? The difference would be that a set is going to give us a Boolean indication. What's the other platform you're streaming on? So I'm streaming to YouTube, Twitch, LinkedIn, and TikTok. Links are in the bio if you want to go see the full screen over there. Thanks for asking. So a set will give me a Boolean indication that that I have seen this character before. You might think, isn't it more efficient to store the position rather than the Boolean indication? I can have a cardinal indication, not just that I've seen a character, but where did I see the character? We did this exercise yesterday, and I went through a bunch of performance tests, and it turns out that the logic required for stale handling. So we're dealing with a sliding window, basically, and I only care if I've seen it within my window. So the logic required for stale handling on the cardinal is large enough that it just erases any gains from storing the cardinal information in the first place. So I actually prefer the set for simplicity, and because it doesn't give us any additional benefit to deal with the a hash map or a dictionary. Okay, so we're content with a set. And I just need to check every character in here. So I'll say for R, for right. Let me initialize my left pointer. So we're doing a sliding window, basically. So that's my left, and then my right is just going to be as far as I've come, and I'll move left as needed. So for right in range. It's going to be the range of the length of the string. Here I'll just mark it to do, and then we'll eventually come out with the I longest, or like I max substring size. So we'll initialize this to 0, and this will be recalculated as the maximum of whatever it is, and then the current substring size. And we can take a little bit of a work backwards approach here. So now we can calculate the current substring size is going to be the right position minus the left position plus 1. And you could underscore IDX those if you want to make it clearer that these are the indexes, right and left, rather than the values. But I think it's clear enough to me. Okay. So this is how we calculate the distance for right and left. We have right here. Now, what is left? This is the part we need to handle now. Left is going to be 0 in the best case. The best case is when we've never seen a duplicate. But as long as we've seen a duplicate, then we will need to move left. And in fact, we could have many duplicates in a row, 2, 2, 2, 2, 2. So we don't want to use a if, we want to use a while, so that we keep incrementing it before we calculate the substring size. So while left has been seen. So here I'll say left char, which is going to be left of S. So while left char and seen, left plus equals 1. We'll just keep iterating it until we haven't seen it anymore. We can also make sure that left is less than or equal to right. In theory, that should never hit, but that will prevent us from having an out of bounds error. In theory, that should never hit, though. Let's see what's going on here. Output of 8, expected 3. So this looks like my left is never getting reset because this is too large, right? And it's never getting reset because I'm not saying that I've seen any characters. So this condition never is true. Seen, I need to say that I've seen this character. Seen left char at right. Seen left char at right. Set does not support item assignment. That's on me. Sorry about that. So the way to write this would be seen seen.add left char. And since we're doing this instead of the map with the index, I will need to drop it here. So it's basically like, is it remove? Remove it while I'm doing this while. And what if I have 2, 2, 2, 2, 2? This might not work because I might need to re-add it up here. So while the left character is in scene, we are going to increment left. And we will restate this. Let's add it over here. Let me comment this. How about that? Still wrong. So this worked. Let me think about why that worked. So in the case where I say one, like A, B, 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 C, A, B, 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 C, right will be on the second B in the duplicate case. So let's do a test case here. Did this just pass our test cases, or is this actually a correct result? I think this is the correct result, but I need to remind myself about why. So we're considering the case where I'm on the index of 2, the second B. So this is the duplicate case. So B is in scene. B is in scene. Left is less than right. Yes, it is, because my left will be at 0 currently. So I'm saying that I haven't seen B anymore. And I'm moving left to the 1, okay? And I'm moving left to the 2. This might be like a false pass. Okay, let me do another B up here. So now let's see. Now let's consider the case where I'm at this B over here. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. So I'm on the 7 index of an 8 char. Consider IDX 7. Oh, we're getting right up to the 30-minute mark. Oh no. I mean, I'll just tap submit if I need to, but I want to understand why. Okay, so now I'm on the 7th index, and I have seen B on the 6th index, right? And so 6 will be less than 7. That's good. And so I'll remove it, and then I'll add it. Oh, no, I don't add it. I'll remove it, and then I'll increment left. Okay, it makes sense. It makes sense because so if I switch this to an if, does it still work? Okay, it doesn't need to be a while, it seems. Wrong answer. Ooh. I'll put 1 expected 2. Let me change it to a while and see if that fixes it. I think the reason is that you will only ever have one dupe, is why it doesn't matter if it's a while or an if. You will only ever have one dupe, so it doesn't actually matter if you use a while or not. Why did this fail? Am I calculating size at the wrong time? So here, in the case of AU, we start at 0, A goes through. A is 0 minus 0 plus 1. So in the case of A, we get 1. We take the max of 1 and 0. The max substring becomes 1. Now I'm on U. So the left char is U. It is not in the scene map. And so I add it here. And then I take 1 minus 0 plus 1. 1 minus 0 plus 1 should be 2. All right, let's go look at the solution. Let's go look at the solution. It feels really close, but I hit my time box. Let's see. Oop. Okay. Set 0, 0, range len s. Oh, it's not in VS Code. So set 0, 0 for right and range len s. That looks similar. While it's in the char set. I can understand why my code has a flaw, but I don't understand why it would trip on the AU test case. So the reason the code might have a flaw is not because of the BBB case. It's like an ABAB case where there are 2 duplicates of different characters. Let's keep reading. And then I have a boundary condition and he doesn't. Would that create an issue? Let's get rid of my and clause and see if that helps. It is a difference. Okay, that didn't help. Good. I would be a little bit confused if that helped. Char set, remove the current character. Remove left character, left of S. Oh, he's looking up the right of S. Okay. Yeah, that's what's wrong. I'm looking up the left of S. I should be looking up the right of S. So I want to do dupe detection on my right character. And that's why I have an off by 1 issue. Left char is not defined. That's okay. Right char and scene. And now we don't need to check left is less than right because we're at the right hand. We're at the right hand. So how about this? WKEW. So if the right hand holds a dupe, that will be an issue. So now does the while help us? No, the while doesn't help us still. There's something wrong here. So if my right char has a dupe, I am incrementing left. So what I should be doing is dropping yeah, this has a wrong thing. Let's look at the solution. While the right character is in the character set. Remove the left character. That's the pivot that I'm missing. So what I did is I said, oh, I ran into a dupe. Let me drop that and revalidate. But what I should be doing is, oh, I ran into a dupe. I need to drop every letter along the way as I move my left. Okay. So here, this should be the left of S. So I removed the left of S. And I increment left, and then I add right. Okay. If duplicate, skip. Yeah, that's the idea. That's the idea. But you could have some intermediary non-duplicates that you're dropping, because I could have like A, B, C, C, where C is the duplicate, and I need to drop A and B. And so A and B are not the duplicates, but I need to keep dropping them. Does that make sense? Because I need to get to the point where I have C, drop it, and then continue. All right, so let's look at the code difference at this point. So range len s, I get my right char. He doesn't extract the variable name, but he still gets R of S. Here I said if. Let's see if the while helps me now. Yeah. So we do need the while. And the reason that flipping over, so if we're on the left hand, if we're tracking the left hand, we don't need a while, because we'll only ever be off by 1. But if we're tracking the right hand, I could have the ABCC case where I'm off by more than 1. So there should be a paired, I should be able to have this. So I sort of remembered the while, and then I justified removing it. But what I should do is have an indication that the while is not needed just because of fast forwarding left. The while is needed because of fast forwarding left while pointing it right. So if I can remember that, that will help me remember lines 8 and 9, not just one or the other. Great. So we'll submit this. We got the right answer, and we are on to today's problem. We got about 20 minutes left, a little over 20 minutes left. Linked list cycle. Let me close these out. There's no solution there yet. That's great. So let's read through the problem. Given head, which is the head of a linked list. So it is a list node we can see based on the type definition. It's not a head pointer, it's a head node. Quick reminder, if you're on any of the channels, please follow the page, like and comment for better reach so that the algorithm will send this content around. You can also sign up for free at latterly.io. Whether you're already a programmer and you want to come share your knowledge, there's a bunch of people, including myself, that would appreciate that. Or if you want to learn to code, it's a great place to come learn to code. Okay, so given the head of a linked list, is it singly or doubly? We don't quite know yet. Well, we can know based on the type definition. So it has val in next. So we know it's a singly linked list. Even the code comment says a singly linked list. So we're given the head of a singly linked list. Determine if the linked list has a cycle in it. Okay, so intuitively, we're just following along. And if we never hit none, then we have a cycle. Well, that's not a very good way to do it. Instead, what we should do is if we see a node that we've already seen, and in the worst case, the answer is we'll traverse every node and we won't have seen. So it could be up to an O of n cache and performance. Up to an O of n cache and performance. Okay. In the worst case, I traverse the whole list. In the worst case or the best case. In any case, I must traverse the whole list. So time complexity is O of n. I should keep a cache of seen nodes, which may grow to the size of all nodes in the limit. So memory complexity is O of n. And the strategy is simply to loop until I see none or a seen member. None or a seen member. Fast, slow pointer, no Floyd's algorithm. Oh, don't cheat, man. You're telling me the answer? That's so lame. That's so lame. Yes, you're right. You can do it without a scene map. Thanks for reminding me. Boo. Shivy told me I can do this with 2 pointers. No problem. You're right, though. Let's see. One is the brute force and one is the optima. So should I just go straight for the optima? Let's do it like I do in an interview. We'll do a brute force, then an optima. Realistically, if I thought of the optima in the interview, I would just speak to the brute force and then I would implement the optima to save time. So let's do that. So let's speak to the brute force, which we've already done. So we get down here. The strategy is simply to loop until I see none or a seen member. Can I do better on time or mem complexity? I can potentially have 2 pointers at different speed. If one encounters the other, there is a loop. This is not slower asymptotically. And it turns memory into constant space. So let's do that. Okay. So here I'll say fast is 0 and slow is 0. And then I'll say while fast node and slow node. So fast node is going to be head. Is it called head literal? Yeah, it's called head literal. So fast node is head and slow node is head. I don't think I need a slow pointer. I think I can just use the slow node. That was a lie. I want them both. We'll see if I can refactor later. While fast node. To do, and then what do I return here? Return false. So what direction is the Boolean? We're returning a Boolean, but which one means what? Let's look at the examples. So false, there is no cycle. False if there is no cycle, and true if there is a cycle. If has cycle, return true. And then here there is no cycle. Okay. How do we know if it has a cycle? We know it has a cycle because fast node is slow node if they ever run into each other. And then else, fast node equals node dot next. I can either mod 2 or I can double next. I think either will work. But if I double next, then I don't need to have these extra pointers. So let's do that. So the fast node is going to be next.next. And the slow node is node.next. To do possibly null. Possible null error. So what if node.next.next yeah, if node.next is none, then I can't call next on none, right? So we'll just break this into 2 lines. So fast node is node.next, and then we'll say if fast node is node.next. Else return true, or else return false. Wrong answer, boo. So head is 1, output is true, expected false. Let's see, how did I return true? Oh, because it's on the first iteration. On the first iteration. So has cycle. I shouldn't do this up at the top. Yeah, that's fine. We'll do our node. We'll do our node navigation first. I think that makes sense. Let me take care of an edge case. If head.next is none, return false. So there will be an edge case where like even the slow node, if I navigate the slow node by 1, it's already none. And I'm just going to handle that edge case because I think it will make my code nicer. I could be wrong about that. If head.next is none, we'll return false. Okay, so now I'm saying while fast node, we're guaranteed to hit this once, and I want to do my navigation first. Navigate first to avoid false true on first iteration. Okay, so we're going to navigate first. So where's our navigation logic? It's down here. Let's cut this. Okay, so fast node is node.next. If fast node, node.next again. Fast node moves twice, if possible. And then else ran into none, so there's no cycle. Great. And then the slow node is going to move once. And now we'll ask if we have a cycle. If it has a cycle, we'll return true. And then I don't need the else case anymore. It will just iterate. This is kind of nice because it flattens, like I had a nested if, and now I just have a singular if. So that's cool. Node is not defined. Did you mean mode? No, I didn't. I meant head. Oh, hold on. I meant fast node. So fast node is moving twice, and slow node is moving once. Cool. All right. None type. Whoa, has no attribute next. I thought I guarded against this well enough. Okay, hold on. What did I do? I guess a better a better way to do this is just to not handle that edge case up front. I'll just check it every time. I'll say if head.next. So here I'll say if fastNode.next and slownode.next. I want to know if either of them are none. Okay, so that's a better guard. If not fast, if they're not both here, that's a better guard. So if they're not both here, then there's not a cycle. Okay, so if either is none, there's no cycle. Navigate first to avoid false has cycle equals true on the first iteration. And that's still a valid comment after the update. It's still a valid comment. Really, I don't think I need that return false down there, do I? Yeah, I'm guaranteed to hit something, and the cycle is the while condition is internally complete, basically. Okay, so I think that does it for today. We got through all of our goals, yeah? Under an hour, go team. And the goal is to hit palindrome linked list tomorrow. So yeah, come say hi for that. Thanks for being here. Talk to you.